Hi everyone, I want to show you the simulation, how to use the simulation for the torque experiment. As some of you asked for help how to use the simulation, so I'm making this video for that. I hope it will help. So you just click on the simulation, and in the simulation you need to go to Balance Lab, as the instruction here tells you choose Balance Lab. Don't forget to remove supports under the board. So let's actually go back and do that. So if you click on the simulation, it will open in the Intro tab, which you can stay and play with it a little bit just to get a hang of it. But the instruction, as you can see here, says choose Balance Lab. Don't forget to remove the supports under the board. Let's do that and remove the supports under the seesaw. So after that, it says select following options in the right corner of the screen: mass labels, level, rulers. Mass labels, level, rulers. Now 3 of them are clicked, so we can play with it. The first question, first question is two masses, one on the right, one on the left. Pivot is basically where your seesaw is balanced, which is this point here. So on the left, it says 10 kilogram on 1 meter mark. Let's do that. 10 kilogram on 1 meter mark on left. And you're supposed to balance this with 5 kilogram on the right of the pivot. Instead of 5 kilogram, I'm going to use 20. And so if you put anywhere, you will see it's not going to be balanced, and 20 is more than 10, so it's going to be actually asking for a closer location than 1, as you can imagine. So you're going to just try different locations and see that 20 is going to be balanced at 0.5. Instead of 20, you need to use 5 and do this and record the location that you're asked to enter. Location of 5 instead of 20 you will use. And the torque is, well, I made a video for how to calculate torques in this video, so you can please watch it to find out how. CW is for clockwise, CCW is for counterclockwise. So as you can see here, 10 kilogram is trying to rotate the seesaw in this direction, which is counterclockwise, and 20 is right now, if you remove 10, you will see trying to rotate it in the clockwise direction. So I hope that part is clear. Second question is giving you 3 different masses, 2 on the right of the pivot, 1 on the left. 1 on the left is the same, 10 kilogram at 1 mark on the right, 10 kilogram on the left of the pivot at 1 again. So we are not going to touch this side, but there's going to be another one over here. Instead of 10 and 5, which is your question, I'm going to use 5 and 20. Let's make another 5 here to the right side. So because it was unbalanced, wherever I put 5 is going to basically destroy the balance. So I need to put actually 20 somewhere closer than before, so that I can basically compensate with the 5 kilogram I have. Let me try here. So it's basically drag and drop, really. You can see now that I have the balance. So instead of 20 and 5, you will do this with 10 and 5, and then write their locations for 5 kilogram and 10 kilogram brick. And in given questions, sometimes you might have multiple answers, which I tried to find out all of them and entered. And if you think your answer is definitely correct, which means that you're seeing this balance. If I'm missing it from the accepted answers, you can write me an email and tell me that you have balanced the seesaw with a certain combination of locations, and yet you get it wrong in the assessment. So I can check and give you the points, but I believe I did work hard on that so that I would figure out every possible combination of locations for these different weights. So, and then again, you will calculate the torques in clockwise and counterclockwise, and in this setting you have 10 kilogram trying to rotate in the counterclockwise, 20 and 5 in the clockwise direction. So the torque from 20 and torque from 5 is going to be added to give you the total clockwise directional torque, as I try to explain in the video, hopefully. In the third one, it's 5, 10, 15 on the right of the pivot, 20 on the left of the pivot at 1. 20 on the left at 1. Wait. let me put this in here, 20 on 1 mark, 20 on 1 mark on the left, 5, 10, 15 on the right. 5, 10, 15. Let me put 20 instead, like I don't want to do the lab for you. So, of course, this is going to happen. Let me put it here. Again, in this one, for example, there are multiple possibilities, like to which location you can put it. That's why I worked hard to find out all possible combinations of locations for these different masses. And right now I might not be able to find it really, so because this takes time. That's the experiments, right? So let me try this. Okay, yeah, I think I got this one. All right, yeah, so then you will basically enter the location for 20. In my case, it's 20, 10, and 15. In your case, it's going to be 5, 10, and 15. And write their locations in the boxes you're given here, and then find out the total clockwise and counterclockwise torques and enter here. I hope this is going to be helpful for your experiment. And you have these mysterious objects A, B, C, D. Let me see. The A, B, C, D is somewhere here. They were, yes, mystery objects here in this left and right arrows. You can find them. So basically, we'll use A, B, C, D to balance and figure out their masses. Okay. One thing here that you need to pay attention to, as I try to give it in instructions. When you calculate the torque, as torque is force times the distance to the center of rotation. Force is the gravitational force, right? You're given masses. Mass is not a force. Gravitational force is mass times gravity, which is G, right? So it is here mentioned that use G as 10 for, it's easier. That's why. So basically the force here is the weight of the mass you're using. So if you have like 10 kilogram here, it means 10 times G, which is 10. 10 times 10 is 100 Newton. And 100 Newton here at 0.5 mark, so the torque from this one is going to be 100 times 0.5. So pay attention to those details, which should basically hopefully give you right answers. Finding unknown masses instructions are over here as part 2. So in the balance lab still, you have the same setting. You find the mystery objects, which I showed you how to find them, A, B, C, D, balancing each of these against 10 kilogram brick. And to do this, locate the mysterious object individual starting with A at 1 mark on the right side. So what you're supposed to do is just get rid of all of that. And put A on 1 mark. Is it right or left? I'm not sure. To do this, locate mystery objects individual starting with A at 1 mark on the right side. So it says on the right side. Okay, and then go back and find 10, and on the left just put it wherever you need to balance this, and from this equation you can solve for the mass of the A. Okay, so if this counterclockwise torque is created by this 10 kilogram mass at 2 meter mark, you can equate the torque created by this to this one and solve for the mass of A. And again, please watch the videos I made for this experiment. I hope that will help. And let me know if you need more help on this experiment. Have a good day and good luck.